framework in an easy way. Now, before you use Spring Boot, you need to understand what the Spring framework is all about. And that's exactly what we'll discuss fairly quickly here in this video. It's assumed that you have some familiarity with Spring, but if you don't, you can get started here. If you've been a Java developer for any length of time, it's quite likely that you've used some component or the other which is part of the Spring framework, because Spring is a Java framework that provides a convenient way of integrating disparate components into a working enterprise-grade application. The Spring framework relies heavily on inversion of control to bring these components together. Managing dependencies within your application is a hard task, especially in Java when you have a number of libraries that you could depend on to get your task done. Inversion of control implemented using dependency injection makes this easy in Spring. A common scenario which you might have encountered is to use Spring modules such as Spring MVC to build web applications. But Spring is so much more. Spring refers to an entire family of projects which support a wide range of applications. Spring supports a wide range of enterprise-grade applications, whether they're web applications, long-running batch processing jobs, or any other kind. You can use Spring with simple cloud-hosted servers, standalone batch workloads, and integration workloads. A common factor that you'll encounter across all enterprise-grade applications is their complexity. There are different components which perform different actions, and these components have to interact with one another. These components might be dependent on one another. Managing dependencies is an important part of any application. Handling and managing these dependencies and ensuring that every component has access to all of the classes that it depends on is an important part of application development. Now, dependencies cannot be managed in an ad hoc manner. This will suffice for simple dependencies, but within an application, this will soon get out of control, which means you need some kind of design pattern to manage these dependencies. Now, design patterns are great and they help you build robust applications. However, design patterns are often not sufficient by themselves, because design patterns tell you what best practices you need to follow, but you still need to implement them. The onus or the responsibility is on the developer to implement these design patterns. This means if you're working on a large team of developers, it's quite possible that inexperienced members don't follow the pattern perfectly. You need a way to shift the responsibility from developers to the framework, and this is what Spring does so well. Spring uses inversion of control, or IOC, implemented using dependency injection to free the developer from the burden of managing dependencies. When you use the Spring framework, you can configure the components of your application using either Java annotations or XML configuration files. A component simply has to declare its dependencies, and the Spring framework will take care of ensuring that the component has access to the classes that it's dependent. There are a large number of Spring modules available that allow you to work with Spring, where you write just simple methods to perform very complex tasks. For example, let's say you need to connect to a database and run queries on this database. Spring allows you to set up database transactions with simple Java methods without you having to deal with transaction APIs. Spring makes it very easy for you to expose HTTP endpoints from your applications that can respond to HTTP requests. These HTTP endpoints can be set up without you having to deal with servlet APIs. Spring allows you to configure message handlers which can send messages between the components of your application, and you don't have to deal with the Java messaging service APIs directly. And finally, when you work with the Spring framework, you get monitoring support without dealing directly with JMX APIs. So as you can see, Spring allows you to harness the functionality provided in its different modules in a straightforward manner. Here is a big picture view of how exactly the Spring framework works. When you're working with Spring, you're typically writing your code in the form of business objects that are POJOs, or plain old Java objects. These POJOs, which are your business objects, will be managed by the Spring container. In addition, you might specify additional configuration metadata for your object. This can be via Java annotations or via XML configuration files. This configuration metadata will be applied to your business objects, and in the end, you'll get a fully configured system that is ready for use. The core fundamental building block of Spring is the Spring Bean. Spring Beans are objects that form the backbone of your Spring application. This can be user-defined beans or beans that are available as a part of the Spring framework. The basic feature of Spring Beans is the fact that they're completely managed by the Spring framework. Their entire life cycle, starting from creation, the way they work during their lifetime, and deletion, all of this is handled by Spring. Spring Beans form a core feature of the dependency management system available in Spring, the inversion of control. Inversion of control is a process by which objects define their dependencies and an external container injects those dependencies into the object. Any Spring Bean within the Spring framework only has to state what its dependencies are. It's not responsible for creating instances of those objects, and external container will take care of this. As a developer, when you develop your own Spring Bean components, you only have to declare what your component is dependent on. You are not responsible for creating or instantiating those dependencies. In order to manage dependencies using dependency injection and the inversion of control mechanism, Spring depends on these four components: the bean, the service, the injector, and the process of injection. A bean is any object within your application that depends on the behavior of another object. A single bean can have multiple dependencies, and other beans can depend on the bean that you create. The term service typically refers to an object that the client bean depends on. The service is what exhibits the behavior that the client bean uses. The injector refers to the code that is part of the external Spring container, which tells the client bean which service to use. And finally, the way the client bean, a component within your Spring application, gets reference to the right service which has the right behavior is via the process of injection. Here is a big picture view of the modules included as a part of the Spring framework runtime. You have data access and integration modules that use JDBC, ORM frameworks such as Hibernate. All of these serve to abstract you away from the transaction mechanics of the underlying database. You have web-related modules as well, which help you build REST services and web applications. You have modules that enable aspect-oriented programming, where you can write code to extend the functionality of existing components. You have modules for instrumentation and messaging as well. At the heart of it all is the Spring core container, which takes care of dependency management using dependency injection. There are also a number of testing frameworks that work with Spring, allowing you to test your application end to end. As a Java developer, anything that you need to develop a fully fledged production-ready application is available in Spring. You simply have to use the right component, set up the right configuration either in XML or via annotations, and you're good to go. I won't discuss each of the Spring modules in detail. You'll be encountering many of these modules when we actually build our applications using Spring Boot. But let's discuss Spring MVC briefly, because we'll use that a lot. Spring MVC is the framework within Spring that supports the use of the model view controller design pattern for building web applications. The model is the representation of the data that you want to show to the user, the view is what is rendered to the user, and the controller manages interactions between the model and the view. Spring MVC uses the servlet architecture, a simple overview of which is present here on your screen. You can see that the web browser makes HTTP requests and gets HTTP responses from the web server. Within the web server, Spring MVC has a servlet program running which will look at the incoming web request and get the right handler to respond to that web request. The response handler responsible for that web request may process the web request by accessing a database, querying a database, or updating a database. Once the handler has finished processing the request, the response is sent back to the user. When you're building a fairly heavyweight application using Spring, you might find it hard to manage all of the dependencies that you need. Spring can be hard to work with when you first start off, and this is where Spring Boot really shines. Spring Boot makes it easy for you to work with Spring. Spring Boot is not an entirely new framework. In fact, it's an extension of the Spring framework. Spring Boot includes all of the same modules that Spring does. The whole objective of working with Spring Boot is to simplify how you develop your Spring-based applications. Spring Boot does this by automatically pre-configuring virtually all of the third-party libraries that you'll use. It's quite possible that you develop Spring applications using the Spring framework directly, and this can get hard, especially as the number of components that you work with increases. With Spring Boot, you'll find that your Spring applications just work. It seems almost like magic. If you work with Spring directly and you switch to Spring Boot, it's almost magical and hard to believe how easy Spring Boot makes everything. Let's discuss how Spring Boot simplifies Spring. It uses auto-configuration. Auto-configuration attempts to automatically configure your Spring application based on the jar dependencies that you've added. Based on the dependencies you have in your app will be configured automatically. Spring Boot also makes use of the parent pom.xml. Instead of explicitly specifying all the dependencies and versions that you need within your pom.xml in your Maven build configuration, you'll simply use a parent pom, which has most of the dependencies pre-configured with the right versions as well. The reason why Spring Boot is so much easier than working with Spring directly is because Spring Boot takes the opinionated approach to setting up your application. This opinionated approach on the part of Spring Boot is what makes it easy to create standalone production-grade Spring-based applications that just work. What exactly does it mean that Spring has an opinionated approach? In software development, this term refers to an approach that intentionally reduces the flexibility available to the developer by making choices on behalf of the developer. This opinionated approach of Spring Boot basically means that you as a developer have to give up some control. The reason why your Spring Boot applications just work is because Spring Boot automatically provides implementations and sensible defaults. You can choose to go with these defaults if you want to, and things will work out of the box. This reduces the flexibility that you have as a developer, but overall simplifies the development process. It's important to understand though that this opinionated approach doesn't stop you from making granular configuration specifications for your app. You can still configure those things that you want to and use the defaults for the remaining components. I'll give you a few examples of Spring Boot's opinionated approach. Now, when you use Spring supports several build systems. You can use Maven, Gradle, and others. That choice is up to you. When you use Spring Boot, the recommended build systems are Maven or Gradle. Spring Boot doesn't really have great support for the Ant build system. Spring Boot, in fact, works best with a build system that can pull artifacts published to Maven Central. So here is Spring Boot's opinion to get things to just work. Use a build system that works with artifacts in Maven Central, which is why we'll be using Maven for all of our demos. If you set up a standalone Spring application, you know that Spring needs detailed dependencies and corresponding versions to be specified by you, the developer, before you can even get started. With Spring Boot, you can simply use the starter dependencies. These starter dependencies will pull in sensible defaults on your behalf. If you need to change those defaults, you'll need to specify additional configuration within your pom.xml. But these starter dependencies lets you get up and running in no time. These starter dependency templates are an important part of Spring Boot. So what exactly are they? These are built-in dependency descriptors that you include as a part of the pom.xml file for your Spring Boot application. A starter dependency descriptor will contain the granular dependencies and versions for all of the components that you need to build that particular kind of app. It'll pull in and manage all dependencies, including transitive dependencies. With these starter dependency descriptors, all you need to know is the kind of Spring application that you're looking to build. Let's say you want to build a Spring Boot web application. Spring Boot Starter Web is the dependency that you'll specify. This will pull in all of the individual libraries that you need, including third-party integrations with Apache Tomcat, Jetty, and Undertow. If you want to include unit tests and other kinds of tests along with your Spring application, you'll also include the Spring Boot starter test dependencies. You can specify multiple starter dependency templates. Let's say you're planning to build a UI-based application and you need a template engine that allows you to render views. You can use the Spring Boot starter thime leaf dependency. And these are just a few examples. As you work through the demos of this course, you'll find that there are many starter dependencies out there. You don't have to worry about the granular libraries and versions of those libraries. You simply specify the starter template, which simplifies your pom.xml file, because you don't need to explicitly specify the third-party dependency within this file. In addition, you don't need to specify the version number for each explicit dependency. You only specify the version for Spring Boot, and then Spring Boot will make sure that the versions of the individual dependencies all work with one another. They interoperate. Most of the dependency management complexity is part of the parent pom.xml that Spring Boot manages and generates. It's not your responsibility as a user unless you want some very granular configuration. What you create will be the user pom.xml, which is fairly simple and only specifies the starter dependencies. Let's discuss some more examples of how Spring Boot makes things easy. In Spring, as a developer, you need to specify the dispatcher servlet mappings and other configurations within your web app. With Spring Boot, all of these beans are created via auto-configuration. What exactly is auto-configuration? This is a way that Spring Boot uses to automatically configure your Spring application based on the jars and other Java dependencies that are found on the class path of the application. Spring Boot basically looks at the class path of your Java application and says, oh, here are all of these jars. This Spring application needs these jars. Make sure they are automatically available to the Spring application. The auto-configuration feature in Spring Boot relies on specific Spring annotations, which are variants of the at configuration annotation. Each at configuration annotation is an opinionated default specified by your app. Now, these at configuration annotations are used conditionally, which means that if you have overridden the default specification for some property, your overridden version will be used, not the default. Thus, Spring Boot respects user-provided defaults. So if you don't want the default specification, you can override it. Otherwise, the default specification is there for you to use. Spring Boot auto-configuration automatically detects and adds beans that you haven't explicitly manually configured. Within a Spring Boot app, you need to opt into this auto-configuration by adding @enable auto-configuration or @Spring Boot application to the entry point of your app. When we write code in just a little bit, you'll see that we discuss these annotations in a lot more detail. Now, auto-configuration is non-invasive, which means you automatically get sensible defaults, but you can replace individual implementations by defining your own beans wherever you want to. You can disable auto-configured default classes in specific instances using either annotation attributes or properties that you specify in an XML file. The auto-configured components and dependencies in your app are applied conditionally. They're conditional on class. So check dependencies on specific classes before creating the auto-configured bean. Spring Boot does this automatically. They can also be conditional on a specific property. Check dependencies on properties before creating the auto-configured bean. This means that the bean will be auto-configured only if a specific property exists within your app. Auto configuration can also be conditional on missing bean. So create an auto-configured bean only if no user-specific bean is available. Spring Boot will correctly use the default only if no user implementation has been provided. When we work with Spring Boot to build user interface-based applications, we'll extensively use the Thymeleaf template engine, which was also available in Spring. So both Spring and Spring Boot use Thymeleaf, but with Spring, the dependency and configuration for the view resolver must be done explicitly by the developer. But when you use the Thymeleaf template engine with Spring Boot, you only need to specify one starter dependency, Spring Boot starter Thymeleaf, and the Thymeleaf template engine will be available for you to use. So what exactly is this Thymeleaf template engine? Well, this is a server-side Java template engine that can process HTML, XML, CSS, JavaScript, and plain text. Thymeleaf has a large variety of control structures that you can use to transform your data before it's rendered to the user. You'll also find that integrating with the Spring Security module is much easier in Spring Boot than in Spring. To configure security in Spring, you must add dependencies as well as classes, but with Spring Boot, you only need to specify the starter template, Spring Boot Starter Security. Spring Boot makes working with Spring easier by pre-configuring the Spring modules that you need, by giving you starter templates that you can use for dependency management and version control. And finally, Spring Boot also simplifies Spring by allowing you to use the Spring Initializer. The Spring Initializer is basically just a web interface that you can use to set up your initial project structure for Spring Boot. Instead of manually setting up your Spring Boot project, you can use the Spring Initializer and download a zip file with your project and all of the dependencies that you've specified set up for you automatically.